Hi guys, so today we're doing lesson 5.5, which is trigonometric identities. There's a handout on Teams that you need to print and fill in as you watch this video. So at the top of your handout there's a diagram, and it's the triangle that we used to come up with our ratios for sine, cos, and tan. And beside there you'll see we have r squared equals x squared plus y squared, which was how we came up with this radius here. And then we rearrange that to say r equals the square root of x squared plus y squared. Then we have sine theta equals y over r, and that's developed using SOHCAHTOA, where sine is opposite over hypotenuse, so y over r. Then we have cos theta is x over r, and that would be adjacent over hypotenuse. And then we have tan theta, which equals y over x, because it's opposite over adjacent. So we learned last week that there are two angle solutions that produce the same positive ratio and that produce the same negative ratio for sine, cosine, and tangent, and we discovered those using the cast rule. Today, we're going to be talking about trigonometric identities, which we're going to use these ratios for to prove the identities and then to use them in our homework questions. So first I'll start by giving you a definition of an identity. An identity is a mathematical statement that is true for all values of the variables. Right, so below that, you'll see the two identities that we're going to prove today. So I'm just going to show you how these identities were developed. You're not going to be proving them in your homework, but you're going to use these identities to prove mathematical statements in your homework. So first, I'm just going to show you how they're proved so that you can say, like, how did you come up with this? This is how we came up with this. It's not just made up, it's based on facts. And then we're going to use these two identities in our homework questions. So the first identity here is the quotient identity. Now, the quotient identity is tan theta equals sine theta over cos theta. So I'm going to show you how they came up with this. So whenever we talk about an identity, we're going to separate the left side and the right side and show that they equal each other. So the left side is equal to tan theta. And going back to these ratios that were developed using this triangle, tan theta is equal to y over x. So I'm just going to write that below here. Tan theta equals y over x. And I'm going to leave it at that. Then I'm going to go to the right side, which is sine theta over cos theta. I'm going to go back to these ratios again, take sine theta and cos theta and replace them in this over here. So sine theta equals y over r, and that's over cos theta, which is x over r. Now, when I divide fractions, instead of dividing, I can multiply by the reciprocal. So I'm going to do y over r times the reciprocal, which is r over x. Now I have yr over rx. I can cancel out the r's, and I'm left with y over x, which is equal to the left side. And now I have proved this identity. So when we prove identities, we say the left side equals the right side, and then we say QED. And QED represents a Latin statement that stands for quod erat demonstrandum, and it means that which was to be demonstrated. So that was quod erat demonstrandum, and it means that which was to be demonstrated. All right. Okay, now the Pythagorean identity. is sine squared theta plus cos squared theta equals 1. So I'm going to do the same thing I did with the last one, separate the left side and the right side. So the left side equals sine squared theta plus cos squared theta, and the right side equals 1. So going back to those ratios from the top of the handout there, sine theta is equal to y over r, and since it's sine squared theta, I'm going to square that fraction. And then cos theta was equal to x over r, and I'm going to square that. Now, our exponent rules tell us that if the whole fraction is squared, that means the numerator is squared and the denominator is squared. So I have y squared over r squared plus x squared over r squared. Now I'm just adding two fractions. They already have a common denominator, so I can add the numerators, y squared plus x squared over r squared. Now, going back to the top of the handout again, I know that r squared equals x squared plus y squared. So, I have y squared plus x squared. That is equal to r squared. R squared over r squared. Anything divided by itself is 1, and that's equal to the right side. So therefore, the left side equals the right side, QED. Just a little note about the Pythagorean identity. It can be rearranged to isolate sine squared theta and cos squared theta. So sine squared theta plus cos squared theta equals 1, but also sine squared theta equals 1 minus cos squared theta, and cos squared theta equals 1 minus sine squared theta. So we can use any of these three in our homework. All right, now I'll show you how to use them. So, example 1. Prove that tan theta plus 1 over tan theta equals 1 over sine theta cos theta. Okay, so I'm going to tell you right now, as soon as you see tan, you want to use the quotient identity to replace it so that you only have sine and cos in your statement, right? It's easier to work with when you just have sine and cos. So I'm going to start by getting rid of tan. I'm going to split up the left side and the right side. So the right side was 1 over sine theta cos theta, and the left side was tan theta plus 1 over tan theta. So the quotient identity, looking back up, says that tan theta equals sine theta over cos theta. So everywhere I see tan theta, I'm going to replace it with sine theta over cos theta. Plus 1 over sine theta over cos theta. All right, so sine theta over cos theta plus, so 1 divided by sine theta over cos theta would be the same as doing 1 times the reciprocal, so cos theta over sine theta, which equals cos theta over sine theta. So I'm going to write that over here. Now, I simply have two fractions that I'm adding, but in order to add fractions, I have to have a common denominator. So my denominator is going to be cos theta sine theta. So this one needs to be multiplied by sine theta over sine theta. And this one needs to be multiplied by cos theta over cos theta. Now I'm left with sine squared theta plus cos squared theta, and they both have a denominator of sine theta cos theta. Now, the top here, sine squared theta plus cos squared theta, that looks just like this here, so that's the Pythagorean identity. That is equal to 1, so I'm going to replace it with 1. 1 over sine theta cos theta, and look at that, I have equaled that to the right side, so now I have proved it. So therefore, the left side equals the right side, QED. Right, so basically, as you work through these problems, you're just going to be looking for opportunities to switch things out using the quotient identity and the Pythagorean identity. All right, so let's move on to the next page. Number 2. Prove tan x sine x plus cos x equals 1 over cos x. So let's split them up. The left side equals tan x sine x plus cos x, and the right side equals 1 over cos x. So, like I said, as soon as you see tan, you want to replace it with sine x over cos x. So, sine x over cos x times sine x plus cos x. Sine x over cos x times sine x is sine squared x over cos x plus cos x. So cos x in this situation, it's not a fraction, it's like a whole number, right? So that means it's technically over 1. Now, in order to add these fractions, I need a common denominator. So I need the denominator of this one to be cos x. So I'm going to multiply it by cos x over cos x equals sine squared x over cos x plus cos squared x over cos x. Now add the numerators. So I have sine squared x plus cos squared x over cos x. Again, sine squared x plus cos squared x, that's the Pythagorean identity. It's equal to 1 over cos x, and that is equal to the right side. So therefore, left side equals right side, QED. Number 3. Prove tan squared x over tan squared x plus 1 equals sine squared x. So the left side is tan squared x over tan squared x plus 1, and the right side is sine squared x. So again, switch out tan for sine x over cos x. Now, if it's tan squared x, you're allowed to switch it out with sine squared x over cos squared x. That's allowed. So tan squared x is equal to sine squared x over cos squared x, and then that's all over tan squared x plus 1, which is the same as sine squared x over cos squared x plus 1. Now I'm going to do the same thing I did in the last one and add the fractions on the bottom. So I have sine squared x over cos squared x all over sine squared x over cos squared x plus 1. Now I need a common denominator, and my denominator here is cos squared x, so this denominator of 1 is going to be cos squared x. So I have to multiply this by cos squared x over cos squared x. So now I have plus cos squared x over cos squared x. I'm going to continue up here. So I'm left with sine squared x over cos squared x all over sine squared x plus cos squared x over cos squared x equals sine squared x plus cos squared x. Again, Pythagorean identity, I'm going to replace that with a 1. So I'm left with sine squared x over cos squared x all over 1 over cos squared x. Now I have a fraction divided by a fraction, so I can multiply by the reciprocal. So now I have sine squared x over cos squared x times cos squared x over 1. These cos squared x's are going to cancel each other out, and I'm left with sine squared x over 1, which is the same as sine squared x, which is equal to the right side. So therefore, left side equals right side, QED. Number 4. Okay, number 4 doesn't say prove, it just says simplify. So that's a big difference. So proving, we had to show that the left side equaled the right side. Now there's no equal sign in these ones, and we just have to simplify them as simple as can be. So usually like one term. So for A here, I have sine x cos x divided by 1 minus cos squared x. So the the denominator, 1 minus cos squared x is a rearranged version of the Pythagorean theorem, right? Because that is equal to sine squared x. Sorry, that's super messy. So I'm going to replace 1 minus cos squared x with sine squared x. So now I have sine x cos x over sine squared x. Now, sine squared x is the same as sine x times sine x, right? So since the bottom is sine x, I can cancel out one sine x from the top and the bottom. So I'm going to cancel this one, and then I'm just going to cancel the exponent to show that I just have one left. So now I'm left with cos x over sine x, and that's almost like the quotient identity, which is equal to tan x, but it's flipped over. So it's 1 over tan x. And 1 over tan x is a reciprocal trig ratio, which is cotangent x. I'll just write that, reciprocal, and you learned about those last week. If you left it at 1 over tan x, that would also be correct, but this is the simplest version, cotangent x. And then for b, I have 1 minus sine beta times 1 plus sine beta. So in order to simplify this, these are not squared, so they're not the Pythagorean identity. So I can't replace with that, but I'm going to first expand them out. So 1 times 1 equals 1. 1 times sine beta is sine beta. Negative sine beta times 1 is minus sine beta. And then negative sine beta multiplied by positive sine beta is negative sine squared beta. All right, sine beta minus sine beta is 0, so those are gone. Now I'm left with 1 plus sine squared beta. And 1 minus. This is a minus sign. Oops. This is a minus sign here, so this should be minus 1 minus sine squared beta. That is part of the Pythagorean identity, which says 1 minus sine squared beta equals cos squared beta. So this can be simplified to cos squared beta, and that is now simple. All right, so your homework for today is page 310, number 2 to 5, 8, 11 to 12, and 14. And there's a few of those that you need to hand in to me. Just let me know if you have any questions, and I'll talk to you soon.